All right, we're here to learn a new data structure now called a set. Now, a set is defined with curly braces. But if I define an empty set like this, set as curly braces, and if I say type of S, it tells me it is a class dictionary, which means you cannot define an empty set. An empty set is nothing but a dictionary, right? So if I say a set is equal to, if instead of making it an empty set, can I say S is equal to, and over here I'm going to say some values, let's say 23, 22, 21, and 20. Okay, so now if I say the type of S, it's going to say class set, right? Now if I just print S, can you see the values, the numbers which I had written, it changed. Not that it will be changed in ascending order or something like that. No, no, no. But if I access it as saying S of 2, it says set object does not support indexing, which means can I write here in comments that it is it is not ordered, a set is not ordered. Okay, but is it immutable? Is it changeable? No, it is not changeable. Why it is not changeable? Because if I do S of 2 equal to 4, of course you can't change it. It does not support item assignment. Okay, but can I add some element? Oh yes, I can add some element. Okay, if I can add some element or clear or copy or do something like that, right? Pop, or I can remove. Okay, so I can use different methods. Let's do a few methods out here. Let's do a copy method with a copy method will just copy it out. You know what that is. Okay, if I do a pop, it's gonna say remove and return an arbitrary set element. Okay, so let's say s.pop, let's say 22. Pop, what will it do? S.pop, it just pops out one element, 20, right? What else will a set do? S dot, if I want to remove a particular value, I need to use remove, right? So if I remove, it removes an element. If I say 23 now, it's going to specifically remove 23. So a pop just pops out one element. 23, removes a particular element from the set. Okay, with this we have got a fair enough idea about set. Let's add a few elements. S dot add, let me say 23, S dot add 45, S dot add 54. So I have S. Now if I say for every element in S, print I, 45, 21, 54, 20, 23. Of course it does print it out. Is that clear? Okay, so we have sets being printed out like this. But say for example, if I have marks of different students, in a list is defined with square brackets. Okay, so marks, I have something like this. Some students might be there who have got full marks, like 100. Some students may be there who are, somewhere near the range of something like. Some students might be somewhere lower, where they go on to 80, 70, 60, 50. Some of them may be there who have just passed, and there may be many of them. Some of them with, same as 50, 65, 70 again, 75. Okay, I'm just putting some random marks out here. This is going to be marks, which is going to be all of them. Now, if I create a set of marks and I store it in, I can just say a set equal to a set of marks. S, wow, what did it do? It returned for me just one instance of the marks, which means it removed all duplicate values. It just gave me those values. What are the actual marks that people have got, right? You can just check what are the marks. That's it. So a set can be used for getting a single instance of a particular number. You don't need to get multiple instances. What about the next one? Let's understand how to do mathematical set operations. Okay, we have heard a lot about sets, union, intersection, and so on, right? So let's see if we can do that. Let me say if m1 is equal to, okay, so if I do, something like this, m1, let me make two lists, 100 comma 56 comma 100 comma 34 comma 45 comma 78, right? And if I say m2 is going to be equal to 67 comma 100 comma 34 comma 90 comma, right, 99 comma 23, two sets or two lists. If I do set of m1 minus set of m2, what happened? It removed those values which were common in both, right? Just give me a minute, 1 second. So what did this do? This particular thing, what did it do? It actually printed all the elements of m1. It printed all the elements of m1 which were not there in m2. All the elements of m1 which were not there in m2. That means 100 was there, it didn't print that. 56 was not there in the m2, it printed that. 34 was there in m2, it didn't print that. 45 and 78. All elements of m1 except elements of m2, right? Sir, I can do something like this. Set of m1 and set of m2 means what? The elements which are common to both m1 and m2. Or I can do something like this. Set of m1 or set of m2, which means all the elements of m1 and m2, a union of both. If I do set of m1 XOR with where is XOR with set of m2, what happens? Elements which are there in m1 and m2 but not in both. Elements which are there in m1 and m2 but not in both. That is what XOR does. These are a few set operations. Sets are used for mathematical calculations, and as we are going to see, we might do a few operations as we start with a few libraries in advanced IoT or advanced Python for IoT. Hope you understood this basics of set. We go on to the next data structures, that is dictionary, in the next session.